Good evening and welcome on this movie on rebuilding alternators. This is a Jaguar X308 DENSO alternator, 120 amps. This is a Jaguar X300 6-cylinder alternator, also a DENSO. These are basically the same DENSO alternators. Reason for this movie, I've been rebuilding some BMW, Jaguar and Volvo alternators over the past year. Basically for my own stock, for the cars that me and my wife have, but also sometimes to help somebody out who lives nearby and who needs a new alternator. This is a bad alternator, a faulty alternator. I got the guy one of my rebuild alternators and I got this in for rebuilding from the guy. But I don't want to save this one because it has bad damage on the housing. You can see some cracks here on the housing. And this is an X300 alternator that I took from a breaker. Still working but old. And I want to use new parts and the parts from these two alternators that are interchangeable to make one proper X300 alternator. That's why I'm going to do this movie. We're going to take these alternators apart. We're going to see if we can find the fault in that X308 alternator. Probably, possibly we cannot. If it's in the rectifier or in the regulator, I may not be able to measure the fault. If it's worn brushes or worn slip rings or a bad slip ring connection, we will be able to measure with the multimeter the fault that we have. So first what we're going to do is take the pulleys off. Then actually we're going to put the pulley back so we can put the alternators on top. We're going to remove the dust shield. We will then see the rectifier, the brushes and the regulator. We'll take a look, take everything off, separate the housing and dismantle the complete alternator. The downside of this type of alternator is that you cannot get the winding out. The winding is pressed in, and although anything you press in it should be possible to press it out, you will not be able to press this out after so many years of rusting itself shut. As opposed to a Bosch alternator, which I have right here. The winding is actually, the stator winding is held in place by the two housings. And since you can take out your stator winding like that, you can actually lightly sandblast or pearl blast your housing and put a nice new coat of paint on it. Let's get started. Let me remove the pulleys and let's take the dust shield off. Okay, and with those protective covers off, we have we have the rectifier visible. This is your rectifier containing your diodes, and they make sure that the phase leads deliver power only in one direction, meaning that the power is always flowing towards your battery. Right here we have the brush holder. The brushes are actually inside here on the slip ring, which you can already see there. And here you have the regulator, and depending on the type of car, you have a certain regulator with a certain connection, and older cars don't even use a connector. They just have like a thread where you put certain leads on. If you have clear visible burn marks, that will be an indication that you have a problem with your rectifier. I don't see any clear or absolutely visible burn marks. I do see a lot of carbon right here, and I don't see that much carbon over here. So that could mean something when we take those brushes out. Everything here is rusted shut, so I'm going to use some oil to get the leads of the stator winding oiled and to get those two screws that hold the regulator in place and the two screws that hold the rectifier in place. And basically all you got to do to dismantle this part is remove all the screws that you see right here, and everything comes right off. The great advantage of the DENSO alternator, this type of DENSO alternator used on many cars, is that there is no soldering involved on those leads. They are screwed through the eye sockets that they have on the leads, screwed into the rectifier. No soldering whatsoever. You can take the regulator off, you can take the block with the brushes off, and then you can also take the rectifier off. Very easy to do. So let's just put that regulator away. Right here you see the brushes. You see that they're worn in on the shape of the slip ring, and you see that there's not much brush material left. Comparing this with a new one, They both have no longer have spring tension. You can see that the new one has like a lot more area on it left. So this one was definitely getting worn. It wasn't worn out yet because it was on the slip ring, but definitely not new anymore. So this shouldn't be the cause of failure on that alternator, because usually you do not wear out your brushes that far. We can also see the slip ring now. You see side 1 and or let's say surface 1, surface 2, and this slip ring is in pretty good shape. If you look at the slip ring, you'll see that you have a wear-in right here on the middle. That's where your brushes have been running. And as long as that wear-in doesn't go too deep from the original size that you can still see from that dull copper, your slip ring is still pretty okay. And I can see some wear-in right here, but not that extreme. And I barely see any wear-in right here. So this slip ring is actually in pretty good shape. I don't know yet about that one. Now let's take that rectifier off. Usually it doesn't need any tapping because there's been current right here. So that rectifier has always been pretty rust-free because of the current that's been flowing. And as I said before, we only have those leads over here with those bolts, and the rectifier comes off just like that. So these are the leads of your stator winding, and here you have your slip ring. Everything can now be inspected and measured. You see a little orange gasket right here against the dust. If it's still in one shape and you clean it and put some Vaseline on it, it will be good to go for another 10 years, but you can still get them new, so I would just get a new one if you have time on your hands anyway. Now you see these rubber pieces right here on your winding leads, and they are in. This is the outside, so this is pointing towards the edge of the alternator, and this is the inside where you have your rectifier. And right here I have my multimeter. I'm going to put it on sound detection first. So let's see if my rotor would actually be able to get current. I'm going to put my one lead on one of the rings and the other one on the other ring, and you can hear that beep, and that means that there's conductivity through the rotor. Now let's see if we measure that 0.00 something, or let's say 3 to 6 ohms, which is like what copper wants to have. Yes, we have 3.5. That's very good for copper. So this is still in okay shape, and there really barely is any wear on the slip ring. So I think the slip ring would still last for a few years, but yeah, we're going to replace it anyway. And now I also can do the first measurement on the stator winding, but I'm going to explain you why this is only for an indication of the stator. You see that I have 4 leads right here. That means that this is a star winding, and that means that you have, let's say, phase 1, phase 2 and phase 3, and then you have the phases connected into what they call the star point. And you have a star winding, or you have a delta winding, and delta is sometimes also called triangle. If you have a star, you always have 4 leads. You have 3 phases and 1 star point. If you have a delta, you have 6. You have phase 1 with an in and an out, phase 2 and phase 3, and so you have no star point. It is possible, but I'm not too familiar with the exact way they connect alternators. It is possible that you have a delta stator winding, but that your rectifier turns it into a star. Although I don't know what kind of alternator would have this, but I guess it's possible because on your rectifier all your phases are coming together again. So without even measuring anything, we already know that this is a star just by looking at the number of leads we have. And the thing is, since we have all these, since we have the 3 phases connected in the star point, it doesn't really matter what I do, because they're going to be connected to each other anyway, so it should beep at any possibility. Sorry, I still had it on resistance. Okay, so now I know that the leads of the stator winding are connected to each other and to the star point. So that only tells me that the actual stator doesn't have any wiring damage or breaks in its trajectory. Let me show you right here a delta core. This is from a Bosch alternator, and you can clearly see the difference between the star and the delta core. I can already see it's a delta the moment we take the cap off, simply by counting the leads that we have. And in this situation, that lead is connected to this one and these are connected, and these are connected, but there's no connection in between. And if you would measure any kind of connection in between, that would be an indication that you have wiring damage somewhere and that copper is touching each other. Or if you are not measuring any conductivity at all, that would mean that there is a wire is broken somewhere, and that you basically have a phase that wouldn't be functional. In this case, since we have connectivity and conductivity all around, we can already say that our stator winding doesn't have any wire breaks or trouble. It doesn't really tell us anything about hotspots and current leak. It is also possible that you have stripped insulation somewhere or burned insulation somewhere, and that one of your phases is connected to the metal housing through that leak. And in that case, your phase will produce electricity, but it will leak away, or produce current, but it will leak away to the housing. We cannot really measure that with a multimeter this way. So for your backyard repair, this is a good way to check if your winding is okay in general, but your final test will be on the car, and that's when you're sure that your alternator puts out the right voltage and current that you need. Right, so to continue, we're now going to separate the housing by undoing the nuts over here. We then have to tap with a hammer to get that housing to come loose because it's rusted shut. And with that housing, we will also probably pull the bearing, or the bearing will stay in place, and instead we will just pull the bore of the bearing, which is in the housing right here. Let's see what happens. And now we take a screwdriver and we're trying to find a nice place where we can fit our screwdriver without damaging that soft metal. And normally I'd use some more professional tools for this, but my YouTube channel with these old motor parts is all about backyard repair. So let's improvise a little bit. There we go, and now we've got our rotor out at once as well. You got to be lucky with those rotors. This is your shaft position of your driven end bearing, and sometimes this is a tight press fit, and it will not come out like that. Sometimes this is a loose fit. In this case, it's a loose fit, and then you can just pull the shaft right out of the bearing, as happened in this case. We now want to get rid of that rotor. We want the rotor out because this is just a dead piece of automotive alloy. So we're going to put this rotor under my press, and I'm just going to use the press right here and press it out. I'll show you in a minute. Okay, so back here we're pretty much we're almost done with the alternator. We can now press this bearing out. This is the non-driven end bearing, and we press in a new one. Other than that, this is just a piece of steel that we don't need. You can see that there's a ring above on the bearing right here. Don't forget about that ring. We have the rotor right here. The only downside of the DENSO alternator is the way they put the slip ring on the rotor, because they press the slip ring on the rotor, no problem so far. Then you have the leads of the slip ring that go down and that are soldered right here in this position. Almost every alternator I've had the slip ring position similar with two ears, and on that ears they solder the leads that come from the rotor winding. And the great advantage is that if you have those two ears, all you have to do is desolder, remove the leads, remove the slip ring, clean everything, put the new slip ring on, resolder, and you're done. Now in this case I need to hack away at this epoxy resin type of stuff, which is super hard. I then need to hack away at the stuff that you see right here, break the slip ring off, and then put my new leads through that area and solder my new leads right here where it's difficult to reach. It's doable and we're going to do it, but it's just difficult. I can also show you the stator problem. Not that this is a bad stator, this is actually usable, but you can see that the stator is pressed in. This will not come out. I mean, I can pull it, but nothing will happen. If I put the press on it, well, where do you want me to press? So we can also not use a puller on the inside because I would be pulling at the lamination. So we're just going to have to leave it like this, and I'm just going to clean it up, but that's it. I can't paint it. To get that bearing out, we need to remove the 4 bolts, and then we just push the bearing out. So let's remove those bolts. Let's put some oil on it first. And these bolts may also need a tap with the hammer, but let's see. So we've got that bearing plate out, and now the bearing is ready to be pressed out. And this is a bit tricky because you need to position it in such a way that you don't actually press on the housing or on the stator. So I'm just going to put the entire alternator in my vise. I'm going to show you boys in a minute. It's coming out already, but I want a bit more of a cylinder. It's coming out. There we go. Now we got to take care of this bearing. And the problem with pushing on this bearing is that you will destroy that ring over here. So you need to be careful in how you push this bearing out. Let's see what we can do. We're going to use this big bolt, tap out that bearing, and hope that we keep that ring in one piece. Else we'll just have to manually get that ring back into shape. It's just a spacer to keep your bearing in position with some clearance or with some force. Bearing is out. Okay, we're gonna have to redo that ring. We're gonna need to put it back in shape. And we got the bearing out with a like a shim spacer type of ring, a spring ring. So we gotta keep that in one piece. Let's remember that the spring ring was top side, so it wasn't on the side of the slip ring. Now on the slip ring on the bottom, you see we also have a ring. So that's how we got to keep that bearing together to make sure it goes in the way it came out. This was the alternator that was actually working. This is the faulty alternator. I'm going to take this one apart too. Now I'm not going to record all of it because you just saw how to take the DENSO alternator apart. I'll be back when I have this alternator in pieces and when I think I have the cause. Alright, so with both alternators stripped, we have the rectifier of the X308 here. The rectifier of the X300 is right here. You can see that they're identical. It's the same rectifier. And I've got two new ones right here. And I'm going to tell you in a minute why I have two new ones. Okay. So I'm going to take my multimeter. And I'll first show you what a good rectifier is like. We want to see about 500 something, maybe 600 something, in the low 600s ohms from our terminal lead, from our winding to our battery, which is right here. And I see 619 ohms, that's okay. And right here we should see the same. Also 619, that's a coincidence, but okay. This is 590, I think this is the start point. And this should also be, this is 612. So this rectifier is pretty okay. We're now going to measure the other way around. We're going to see what happens if we measure from the battery to the terminal leads. Nothing happens here, and that's good, because we're crossing a diode that's blocking our path. Same here, nothing. Same here, nothing. Same here, nothing. So now let's measure the new one that I have over there and see what kind of values a new rectifier gives us. 576, so that's close to that 600. 578, so that's basically identical. 566. 558. So let's say that you have to be between 550 and let's say 630 and you have a good rectifier, and this is a new one. We also want to see, of course, that the new rectifier goes one way, so let's take care of that. I measure nothing, 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 nothing. So the diodes are blocking towards the phase terminals and the diodes are allowing current towards the battery, so that's good. The old rectifier is good and the new rectifier is good. Let's see what happens when we take the rectifier of the X308. Possibly we can measure something, maybe not. Let's start with that phase lead over there. 6 something, 640, 670, but that could also just be some dirt. Like 627, so that's okay. Let's see. This is the start point. I should get that measurement. Come on. I'm not measuring anything right here from the star. And it's not my multimeter, it's the rectifier, so that's something already. Here we have another terminal lead. That's also 6 something, pretty okay. And here we have another phase. And it does measure something, but almost 0. It looks like I can't say for sure what's wrong within the rectifier, but this is bad. And if I put a sound check on it, we will not measure sound here. And we will not measure sound there. But perhaps we will measure sound here. Ah, look at that. We are measuring sound from this phase. There is one of the terminal ends right here is a phase. And you can see that we are measuring sound one way. That means there's not enough resistance. Very low resistance. And are we also measuring sound the other way? Yes, we are also measuring sound the other way. And that's what's going on here. This rectifier is bad. This phase is no longer functioning properly. The diode from the phase to the battery is bad. And that's probably why this alternator wasn't functioning anymore. Here I'd like to tell you why I have 2 of these rectifiers right here. There's a different part number on these rectifiers. They are the same rectifier. Basically they are the same rectifier in essence. They both fit on the alternator, they both do exactly the same, and they are rated for the same output. A rectifier has a rating depending on the diodes. It's the maximum current that the diodes can handle. If you have a 3-phase alternating current alternator, and you have, for example, a 150 amps of output, you need at least 50 amps capacity per rectifier couple on your phases, because you need to handle that 150 over 3 phases. So that's 50 amps. If you take a rectifier with a maximum capacity of 40, they will burn out. And that's why it's important to know when you aren't sure what rectifier you need, what the capacity of your alternator is, so you select the right rectifier. Now, as I said before, both will work. Both have the same capacity on the diodes. I think it's 50, which is enough because this is only a 120 amp alternator. But this one has slightly different dimensions. It's a bit more narrow, this one's wider. But that doesn't matter. I have fit both rectifiers on Jaguar alternators. So it doesn't matter if you take the broad one, which you're supposed to get, or if you take the somewhat more narrow one, which is used on Volvos or other cars that use the DENSO. They will both fit. Okay, so we have 2 identical rotors here. Both rotors are in okay shape. You always see a little bit of surface rust on your rotor fans, but don't worry about that. If it's not completely crusty, these rotor fans will still last years. We see that both slip rings still have enough material, but I'm going to renew it anyway. And as I said before, the downside of this type of alternator, let me show you, this is a different alternator housing, but just to show you, the downside is that they have this slip ring and its wires completely covered in this epoxy resin stuff, which is incredibly hard. So we need to hack away at this to get it out. We need to hack away at what they have in between the copper. We then need to destroy and remove the old slip ring, clean everything and put the new slip ring in. Now, to do this in a controlled fashion, you take the old bearing. This is the old input bearing. And as you can see, it has a loose fit, so we just slide it over. And in the vise, we put the vise on the bearing, because we no longer need the bearing, and the vise will hold the rotor in place on the bearing. So we don't have to hold the rotor in place by pushing on these fan blades. And with the rotor in position on that bearing, we now take an old flathead screwdriver, and I'm just going to start hacking away at that resin. Just to get it out. The only thing you're doing is hacking away at the resin, getting the wire to become visible, freeing the wire so you can remove the wire and have the area to put the new wire in. I'm just going to hack away at it, speed up the camera so you're not bothered with me hacking at it, and I'll be back in a minute to show you what we're talking about. I've hacked away at the resin. I pulled the 2 leads out for the slip ring. Don't worry, I'm going to get new leads. I can now desolder the lead right here and desolder the lead right there. We'll do that in a minute. And first I need to remove the slip ring and this insulating material. I just need to hack. Now we use the flathead screwdriver to see if our new slip ring is going to sit without an issue. We are looking at any kind of damage that would prevent our slip ring from being pushed on. But so far everything looks okay. And that means we're going to go ahead and fit the new slip ring. We need to put the leads of the slip ring right here in the two pathways that we have. That's it. My soldering iron is heating up. I'm going to use my vacuum cleaner to get that solder air out of here. Once I start burning, I'm just going to put a bit of acid right here and right there on my connection. Then I'm going to let some solder flow in, cool it off, see what it looks like, see if it's solid, if I measure good conductivity, and if all's good, my slip ring soldering is a success. So, soldering the wires to each other on both sides is basically the final thing you do to get that slip ring okay. Now let's see if we still have our conductivity. We do. Let's see if we still have that ultra low resistance. We do. Okay. Now we have the interesting part. We have this two gaping holes and we have that open area right here where we have the new wire running. So you saw that they use some kind of epoxy resin to close it off. And you can get epoxy resin wherever you want to and just use it, that's okay. But I also have good experience using normal bathroom caulk. And you're gonna ask me, or you're gonna say like, what the hell, bathroom caulk? Why would you put that on an alternator? Well, it seals, it insulates, it's sticky, so it actually stays, and it's flexible. And the advantage of it being flexible is that, let's say you make a mistake and you want to backtrack your entire work, you can just wiggle all of the caulk that you used out and you'll have the exact same side that you see right here. I'm not going to do the caulking right now because I would have to wait for 24 hours for it to really cure properly. Instead, I actually have a repaired rotor right here, which I have from my spare alternator that I had to destroy. And we're just going to continue with this rotor. You can see it's the same slip ring. And you can see I also soldered this rotor already a while ago. So we're just going to pretend that we're using this rotor, but instead we're going to use an identical brother. I'm just going to put this rotor away. Going to put that rotor in. Let's, for added good measure that as well. I haven't touched it in a few months. You can see that the copper is already dull. That's good. Now let's check the ohms. Also low, even lower, 2.5 ohms, and that one was 3.2. That's still very low. So we're going to put this one away because I've got to caulk it. Just going to use sandpaper to get that copper smooth again. Looking good. I'm just gonna wait until my soldering iron is cool again, clean everything. We're going back to the workbench and we are going to start assembling this alternator. Alright, so we have the rotor that I'm gonna use. Let's sand the shaft here a little bit so we have a smooth polished shaft to use. I already sanded it a few months ago, so don't have to overdo it today. We had that slip ring checked out, so that checks out alright. Here I have the stator housing with the stator core. As you can see, it looks really nice and new. I put it in my ultrasonic cleaner and it came out like this. Sadly, I cannot respray it because then I would be spraying over the copper, and you want to have that coppery alternator look. That's what makes it look so nice. You could spray it, it's not really an issue. Theoretically, you are insulating your pack even more. But I guess on these automotive builds it doesn't really matter. This is not industry. What I'm doing now is polishing the bore of the driven end bearing, because that bore always has a little bit of corrosion and pitting. The bore feels smooth. That means we can get the driven end bearing in, and we need to do that now because we need to lock it with that plate. Here you see a new driven end bearing. This is actually a Chinese bearing. You're gonna laugh and be like, oh my, are you using Chinese bearings? I gotta be honest to you, yes, and so far I have had no issue with those Chinese bearings whatsoever. I always put a little bit of bearing grease on the outer race to make sure that I now put the grease as conservation on that bore, because then the bore will actually stay okay, I won't rust so easy. You never know when you need to take that alternator apart again. The best way to put in that bearing is using the press. That's the most controlled way. But since we are kinda in a backyard repair fashion, I kinda need to show you guys another way to do this, I guess. So let me take out the old bearing. And since this is a bearing that sits in with its outer bore, we do not want to put pressure on the inner ring. We want to put the pressure on the outer ring, because if you put pressure on the inner ring, yes, the bearing will go in, but you're loading the cage and you don't want to do that. So you want to hammer on the outside using like a bearing race that fits nicely over the outside and that leaves the inside untouched. There we go. Our alternator pulley did the job. Remember, we had that ring over on the outer race. The ring was over the outer race for sure. I then put this old alternator pulley on that ring, and then I just hammered the alternator pulley and this race on the outer race of the bearing that we need to fit actually put the bearing in properly. So that's a success. So now we want to use that plate to lock it up. Alright, so now we have the bearing in and we have the bearing plate in, so the bearing is being held in place. Let's see how best to approach. Let me just get that big pulley. This is an X308 pulley, but that will help us the most now. And I'm just going to put the alternator on the pulley. Now let's take out my new rotor, which I have right here. And let's put a little bit of bearing grease on the rotor shaft so it drops in the new bearing easily and so it doesn't catch any rust. And now we want to drop in our rotor. And since that was not a tight fit, the rotor drops in just like that. And now let's check if the rotor is alright. Yes, rotor looks okay. There we go. So now with the rotor we need to consider if we're going to put the bearing on now or if we're going to put the bearing on later. But first let's not forget that we had a spacer ring down there. So let's get that spacer ring back on. There we go. I'm going to put the bearing on right now. And the socket that I have right here fits over the bearing on the inner race. So that's the way to go. I have a metal plate right here. I still have distance that I can travel. I still need some distance on this. Yes, and now we're all the way there. Alright, so we're going to put that ring over here. I hammered it and it fits again. Then we have that spacer ring. And then we need to fit the housing. Now fitting the housing is only possible in one way because the terminals go through the holes in the housing. And if you have a alternator where you can remove the stator core like the Bosch type, you need to make a picture of the exact way it was fit. Else you fit it in the wrong way. Excuse me, before I continue I'm going to sand the bearing housing right here. Okay, let's see. And you can put the bearing in first, like I did now, and then the housing. You can also put the bearing in the housing and then hammer the housing over the slip ring. I'm going to tap that smaller one. There we go. We should be able to do the rest by just gently screwing those nuts back into place. I wouldn't use too much force. Just your wrist on a small ratchet like you see me doing is fine. Alright, we got that. Alright, and with the non-driven end housing on and tightened with the nuts, this is the first opportunity to check how the alternator is actually spinning, if it's spinning free in the bearings. So let's see. Looks good, no sound at all. Let's see, we had that little rubber ring over here. Let me clean that little rubber ring a little bit. There we go. Rubber in position. I have a new rectifier right here. Okay, got it. Now let's put those rubber shoes back on our phase leads and our star point. 4. Well, this can fit only one way because of our leads, so that's pretty logical. I'm not gonna tighten it down yet. Here you see our voltage regulator that we will fit and position like that. Looks like we need to fit the brushes first. Alright. There we go. This is pretty much the way we're going to fit this alternator, like that. I'm just going to hold it by hands for now. You see a new rectifier, a new regulator and new slip rings. And now I just need to tighten everything down. There we go. And now we're basically ready to put the cap back on and finish this alternator. We need this. We need to fit this yellow protective cap. So we're going to take that yellow protective cap from the old brush holder here and fit it on the new one. And it slides out one way. There we go. Now we're really done. Apologies. This, gentleman, is our X300 alternator repair. The DENSO alternator. I've got the pulley right here. I just need to put the pulley on, but I want to sand and clean and spray this pulley. But here you go. Here you see how free it moves. The rotor is still the old one. The stator core is the old one. But all the other wear and tear parts have been replaced. To sum this up, this is a pretty easy alternator to work on, but the big downside is that you cannot get the core out of the metal housing, and so you cannot really sandblast it. I use my ultrasonic cleaner to clean it, remeasured the core to make sure I have no leak to ground, but that's as far as you can go. If I would spray the housing, it would look better, but I would also be spraying the nice coppery color of the core, and I don't want to do that. So all I got to do now is fit the pulley when I've refurbished it, and we're good to go with this alternator on an X300. Hope you liked the video, and hope you know enough to do your own DENSO alternator rebuild. I'll see you guys in the next video.